everyone, this is Ananta Devnath. Now I am giving the overview of our object recognition project. At first, we have created a new world and added some object onto this world. And to make this world more realistic, we have added collision and physics into this object. Here, physics means included mass density and friction. To make robot, we have added four wheels and we have added distance sensor in front of the robot and camera and a GPS. Here, distance sensor for determining the distance between object and the robot, and camera for detecting the object, and GPS for global positioning. Now, to run the to control the robot, we have implemented a Python code. So let's now run this project. Here you can see that our robot is moving, and if it finds any object, it is shifting right. So detailed parts of our project will be described by my other group. Thank you.
Good afternoon everyone, this is Faria Tasin and I am going to show how I created the world for the robot. Here I have made a rectangular arena for the floor, and then I have created some objects using solid. For example, if I see the cone, I have used solid, which I have named solid 2, and then under solid I have added the translation, rotation and scaling, and under child I have added the shape, and under shape I have chosen the appearance for the object, and under geometry I have selected the shape of the object and height and radius the way I want to fix it. And then for collisions to take place and so that the robot doesn't pass through, I have added a bounding object. For this I have chosen cylinder, and in physics I have added physics as necessary. I have done the same thing for all the objects I have created here, and I have added a box below and a few boxes around the floor so that the robot doesn't fall off. And thank you.
This is Sophia Armin, and I will explain how we have created a robot for our project. First, we will select this add button on the left, and from base node we will select a robot. After selecting robot, we will go into the robot part and rename it as robot, and then in the children section we will add different parts of our robot. First, we have added a shape for the body of our robot, and here in the shape part we have added an PBR appearance, and the geometry of the body is selected box, and these are the dimensions of our robot's body. Then we have added a hinge joint. In hinge joint part, in the joint parameter part, we have added hinge joint parameter. Later, in the device part, we have added rotational motor and named it wheel1, which will be used in our code later. Then, in the endpoint, we have added solid, and under this solid part, there is a children section where we have added a shape, and under shape part, we have added PBR appearance, and the geometry of the wheel is set as cylinder. Later, the height and the radius of the wheels are defined as follows. Then, we have added bounding object and physics to our wheel. And then we have used rotation and translation in the endpoint solid to move our wheel according to our need in this project. And in the joint parameter, the anchor has been set according to the values that are given in the translation part after fixing our wheel's position. In this way, wheel 1 is created, and the same procedure is used to create wheel 2, 3 and 4. Then we have added two distance sensors to our robot. One is called DS right and one is called DS left. Both the distance sensors are being added from the base nodes, and after adding the distance sensor, in the children section we have added shape, and in the shape part we have defined the appearance, and under appearance we have selected PBR appearance, color, and in the geometry part we have selected a box shape for our sensors geometry. Then we have added a camera from the base node, and in the similar way under the children section we have added a shape, a PBR appearance, a geometry of our camera has been set to a sphere. Then we have added a GPS to our robot, and in the children section we have used similar procedure by adding a shape, PBR appearance and geometry of the GPS is selected cylinder. After doing all these things, we have added physics and bounding object in each and every part of our robot's children section. And this is how our robot is created.
Hello everyone, my name is Ronak Muqtadir, and I'll be talking about the controller code portion of our project. So we have done our coding in Python. As we can see, we have imported the robot and camera from the controller library. Then we have set the timestamp to 64. Then we create an object of robot and camera, and we have enabled. We have set the distance sensors name equals to DS right and DS left, so we use it here. Then in the range, it enables the distance sensor with the timestamp. Same with the wheels. We have set the wheel name to wheel 1, wheel 2, wheel 3, and wheel 4, and in range of 4. So because we have 4 wheels, we append and set position to infinity and set the velocity to 0.0. Then the avoid obstacle counter is set to 0. We go in this while loop if it's not equal to -1. If anything but -1, we go in this while loop. So the left speed and right speed is set to 1 if it doesn't detect any obstacle. However, if it detects any obstacle, the avoid obstacle counter will be greater than 0. So we go in the safe condition. Here, the obstacle counter will be decremented and the left speed will still be right. So in this else portion, so if it doesn't detect any obstacle, this if ds get value will be less than 950, and it will go in here, and the obstacle counter will be set to 75. And the wheel, when the next time we go here, it will be 75, so it will not be -1. So we get in here, and obstacle counter is greater than 0, so our obstacle counter will be decremented, and to avoid the obstacle, the robot will turn right. This portion of the code is setting the wheel's speed according to this or this. So this was our presentation on our obstacle avoiding and object recognition enabled robot. Thank you everyone for watching.